So now we continue with our chapter in physics, force and pressure. In the earlier videos of this chapter, we had seen about the different types of forces. What is the force? We saw about the moment of the force, that is how a particular body which is fixed at one point is going to produce a rotational motion. And hence we saw the different things, that in case we want to apply a force, we'll always apply at a distance which is the greatest from the fixed point, so that you need to apply the least amount of force. So we saw that moment was force into displacement, force into the perpendicular distance from the pivoted point to the line of action of force. So that is what we saw in the previous videos. Now we come to the next part of the chapter, and that is pressure. So pressure is force per unit area. That means when I am applying a force, now suppose I am applying a force like this. When I am applying a force, then what will happen? Am I feeling too much of a kind of a force on my palm, on this palm, due to this palm? No. Now, if the same amount of force I am applying with my fingers like this, okay, or with my fist like this, yeah, I feel a bit of more force. I feel that, oh, there's something more. This was comfortable, but this is slightly more. If I do it with my fingers, 4-5 fingers like this, it feels, oh, this is something more. And when I take it only pinpoint and then do with the same amount of force, I feel, no, this is really hurting. So what happened? The force applied was the same, but the area on which the force was applied is becoming smaller and smaller. So force which is acted upon area, okay, force upon area, force acted upon area, that is called as pressure. So we see the pressure, that the force which is acting perpendicular, okay, the perpendicular force which is acting perpendicular over here is called as thrust. So thrust is nothing but perpendicular force. Okay, that means it is the body and this is the force acting on the body. Then this is perpendicular. So this force over here can be taken as thrust. So a force can be applied on a surface in any direction. We know that. We can apply force in any direction. If the force is applied on a surface in a direction normal or perpendicular to the surface, the force is called thrust. Okay. So we can define thrust as the force which is acting perpendicular to the surface. So if the force is perpendicular to the surface, then that kind of force can be given a new term in physics, and that is thrust. So the force acting normally on a surface, normally means perpendicularly, normal means perpendicular, so 90 degrees. So the force acting normally, okay, force acting normally on a surface is called thrust. A body when placed on the surface exerts a thrust on the surface equal to its own weight. So like for example, when I am standing, my body is exerting a force or thrust on the ground which is equivalent to my body weight. So whatever is my body weight, that much amount of thrust is going to be applied on the floor. So the thrust applied by a body on the floor will be equal to the weight of that particular body. Okay, so thrust can be also said to be the weight of the body if it is standing on that particular surface. So a body when placed on the surface exerts a thrust on a surface equal to its own weight. The unit of force is the same as that of weight or force. So here the units of thrust is nothing but Newton, or it is kg. So Newton, I'll not really say, or we'll say it's upon, or kgf. So Newton or kgf will be the same SI units of thrust because it is nothing but force. It's just a kind of force. That's why it is just the same as force. Thus the units of thrust are kgf, gf and Newton. So we have this thing as 1 kgf is equals to 1000 gf, and we have 1 kgf is equals to 10 Newton, or we have 1 Newton is equals to 100 gf. Okay, this is nearly. Why nearly? The actual value is 9.8, so that's why we are just taking nearly 10. So that's the examples of thrust. Now what is going to happen, or what we will see about the effect of thrust. Okay, so the effect of thrust depends upon the area on the surface on which it acts. I showed you the example, pressing this way, and pressing this way by the finger. Here the area is this much big area coming exactly on this area, and hence the thrust which is appearing, or thrust which is acting on this particular body, is distributed to a bigger area. When it is like this, it is distributed to only this area, and when it is like this, it is distributed to only this much tip over here. So you can see that every time the area is going to decrease, and accordingly the effect of the thrust on the surface will be different in each case. Smaller the area of the surface on which the thrust acts, larger is its effect. I told you that when you are pressing it like this, I feel the pain. I can feel the pain over here. But when I do it like this, I did not find that much pain. Here, no pain at all. So when did I feel a pain? When it was sharp. It was pinpoint or smaller area. So smaller the area, more is the effect. Okay, smaller the area of the surface on which thrust acts, larger is its effect. But the effect of the thrust is less on a larger area. So larger the area, lesser the effect. More the area, smaller the effect. Smaller the area, larger the effect. So for example, they are given the examples over here. Let's understand those examples. If you stand on a loose sand, your feet sinks deep into the sand. But when you lie on the sand, your body does not sink too much into the sand. In both the cases, the thrust exerted on the sand is the same. It's a simple thing. When you go to the Jew beach, okay, and you try to walk on the sand, so when you're walking, your feet are going a bit inside the sand, and that's why it is difficult for you to walk, because every time your feet is going a bit inside the sand, and that's why it is difficult. So when you are applying the force, the thrust which is applied on the sand is equal to your body weight. But when you sit or sleep in the sand, do you get inside? Do you feel that array you went inside the sand, or you got dug into the sand? No. Why? Because when you sleep or stand, no doubt the thrust is the same. The thrust is exactly the same, because thrust is exerted by the body weight. Your body weight is not going to change when you are standing or when you are sleeping or sitting. Your body weight is not changing. But the area in contact between you and the sand is changing every time. When you are standing or walking, at that time your foot over there is going to be the area in contact, which is quite small as compared to the whole body. When you are sleeping, the whole back area, the whole back part, your whole body is going to be in contact. When you are sitting also, your whole lower portion is going to be in contact. So accordingly, when you are having the same thrust, when the area of contact was less, that is the feet, you got sunk inside. When you are sitting or sleeping, because the area of contact increased, the effect of the thrust decreased. Okay, so in both the cases, thrust were exerted on the sand was same. However, when you stand, the thrust acts on a smaller area of the sand, and when you lie down, the same thrust acts on a larger area. So that's what we see, that when you are lying down, you are giving a larger area of surface, and that makes it the effect of force a bit less than when you were standing or walking. Similarly, if you hammer a nail holding it with its flattened end resting on the wooden block, you find it difficult to get the nail into the block. Like if I need to take a nail, okay, if I take a nail, let me give you an example. We'll take a, I'll not take a nail, but I'll take this pin. Okay, this is a pin which I'm taking. This is the flat end and this is the pointed end. If I try to hold this and put this inside some particular wood or something, will it be possible for me to do it? No, because this is a flat end and I'm applying the pressure. And when I'm applying the pressure, what is happening? It is getting distributed in the whole area. The same thing if I take this one and this is a pointed part which has got a very thin area and I put it, it is going to pierce inside my hand itself. It is going to be very, very sharp to enter inside. So that's why you see that this pointed part is easy to drive inside a wood or any particular part because the area is too small. Hence the force which we are applying is giving a large effect of thrust. The thrust which we applied is giving a large effect because the area is very, very small. But when you are putting it this way, because the area increases, that's why penetrating it becomes difficult. So that's exactly what they say, that if you hammer a nail holding it with the flattened end and resting on the wood. So if I'm putting it like this, flattened end resting on the wood and then hammering it over here, then it is difficult to hammer it inside. But if you hammer the nail holding the sharp end and resulting on the block, then it is going to enter into the block easily. So this is what we saw in this particular kind of thing, that if you hammer a nail holding it with its flattened and resting on the wooden block, you find it difficult to get the nail into the block. But if you hammer the nail holding its sharp and resting on the block, the nail penetrates into the block easily. The effect of thrust is expressed in terms of quantity called pressure. So this is pressure. What is pressure? Effect of thrust. The effect of this particular thrust, the effect of thrust is pressure. So more the effect of the given thrust on a surface, we say that the thrust exerts more pressure on the surface, and if less the effect of the thrust on the surface, we say that the thrust exerts a less pressure on the surface. So if the effect is more, we say the pressure is more. If the effect is less, we say the pressure is less. So the effect of thrust on any body, on any surface, is hence called the pressure. So we can say that if any particular thrust is giving you less effect, then we say that it is giving you less pressure. Whereas if it is giving you more amount of effect of the thrust, then we call it as more pressure. So more effect of thrust, more pressure; less effect of thrust, less pressure. Hence we define pressure as pressure is defined as thrust per unit area. So hence we have over here the pressure as pressure is equals to thrust upon area. So thrust per unit area, thus pressure can be defined as thrust per unit area. Thus pressure is thrust upon area. It is denoted by letter P, and thrust we are taking it as F, area we are taking it as A, hence we say P is equals to F upon A. Got it? So this is the first formula, that pressure is equals to F upon A, pressure is equal to thrust upon area, pressure is equal to force upon area, pressure is equal to F upon A. Right? This is the first definition, or we can say also the first formula for pressure. Now, we very well know what is the SI unit of thrust and what is the SI unit of area. The SI unit of thrust is Newton. The SI unit of area is meter square. So therefore pressure can be given as Newton per meter square. Okay, it is given as Newton per meter square. And this Newton per meter square is given a new name that is called as Pascal. Capital A and small p is the abbreviation of this thing because it is based on the name of a scientist named Pascal. So scientist named Blaise Pascal was a person who gave lots and lots of readings or lots and lots of study. He did a lot of study of pressure, and so to honor him, the pressure is given the units as Pascal. And because Pascal is the name of the scientist, hence you will always write it in small letters. But when you write it in simple, it will be P capital and A small, that is Pascal. So 1 Pascal, we can say 1 Pascal is equals to 1 Newton per 1 meter square. Okay, that is 1 Pascal is 1 Newton per 1 meter square. So let's see this thing. The SI unit of thrust or force is Newton N, and that of area is meter square, M square. So the SI unit of pressure is Newton per meter square. Symbol N upon M square, or N M raised to minus 2. The unit is also called Pascal, abbreviation symbol PA, capital P, small a, after the name of scientist Blaise Pascal. Got it? So that was the SI unit of the pressure, that is Pascal. 1 Pascal is pressure exerted by a thrust of 1 Newton on a surface area of 1 meter square. So we can define 1 Pascal. This gives you the definition of 1 Pascal. What is 1 Pascal? 1 Pascal is the pressure. 1 Pascal is the pressure exerted by a force of 1 Newton or a thrust of 1 Newton on a surface area of 1 meter square. Okay, 1 Pascal is the pressure exerted by a force or a thrust of 1 Newton on a surface area of 1 meter square. Thrust upon area. Got it? That is the definition of 1 Pascal. So 1 Pascal is equal to 1 Newton upon 1 meter square, or 1 Pascal is equal to 1 Nm minus 2. The bigger unit of Pascal will be kilopascal, which will be 10,000 Pascal. Oh, sorry, 1,000 Pascal. So 1 kilopascal is 1,000 Pascal. Now, but if the thrust is measured in kgf and area in centimeter square, then the pressure is expressed in the units. So if it would be in not in Newton but in kgf, then pressure will be equal to kgf centimeter square. Okay, kgf centimeter square will be the thing if the force or thrust is measured in kgf and the area is measured in centimeter square. We also have one more thing, and that is the atmospheric pressure is generally expressed in unit ATM, that is atmosphere. So that value is 1 atmosphere, 1 ATM is equals to 76 centimeters of mercury column. Okay, it's 76 centimeter mercury column, which is equals to 1.013 into 10 raised to 5 Pascal. Okay, This is the value of 1 atmospheric pressure. 1 atmospheric pressure is 10130 Pascal. Well, 13100. Yeah, 5 zeros. So 101,300 Pascal. We write it as 1.013 into 10 to 5 Pascal. Understood? So this was about the pressure and the SI units of pressure. So we saw over here, pressure is thrust upon area. So thrust is nothing but force upon area, F upon A. F is in Newton, area is in meter square. So Pascal is, pressure is equals to Newton per meter square, that is Pascal. So we define 1 Pascal as the pressure exerted by 1 Newton, by a force of 1 Newton or thrust of 1 Newton on a surface area of 1 meter square. If it is in kgf, then it is kgf centimeter square per centimeter square, or atmospheric pressure is 76 centimeters of mercury column, which is 1.013 into 10 to 5 Pascal. So this is the units and the difference of the Pascal. We now move on to the factors affecting the pressure. So the factors affecting the pressure are, first one, in fact we can find it from here itself. So we have over here, let's see, we know that pressure is equal to force upon area, thrust upon area. So automatically the first thing will be dependent on the area of cross section. We discussed this thing. More the area, lesser the pressure. More the area, lesser the pressure. Lesser the area, more the pressure. So on the surface of the area of the surface on which the thrust X. And secondly, so this is surface area. And second one is force, the magnitude of force. Magnitude of force. So it depends upon what is the force exerting on. Whether it is the force exerted is, suppose I am standing on a particular, let's see, on the beach. And another thing is a small kid standing on the beach. Who is going to exert more pressure? Of course, my body having more weight will exert more amount of pressure, because the force acting by my body, that is the weight of the body exerted by my body, is going to be greater than that of a kid. Accordingly, we will see that depending upon the magnitude of the thrust, it is going to be different. So first we see dependence of pressure on the area of surface. So when you stand on sand, a thrust equal to your weight X on the smaller area, but so it exerts the most pressure on the sand. So when you are standing on the sand, you will find that the pressure exerted by your body on the sand will be much more, because the area in contact between you and the surface is less. That's only the feet area. Similarly, when you hammer a nail with its flattened end resting on the wooden block, thrust exerted by you X on a larger area, so less pressure X on the nail, hence it does not go into the block. But when you hammer the nail with its sharp end resting on the block, the same thrust X on a smaller area, so more pressure X on the nail, hence it easily penetrates into the block. So you saw that also, the nail, if you take the unpointed part, the flattened part and put it, it is very difficult to drive it inside. But if you put the pointed part and then you hammer it, it's very easy to drive in, because the surface area in contact is very less, so the pressure is extremely high. Now they are given an example over here that how the thrust is going to be acting. So let's consider that we have got this particular duster, and the duster is acting over here like this. So automatically the pressure exerted will be distributed along this whole surface area. But the same thing, if I am putting it over here like this, then the surface area what is in contact will be only this much part. So if you take a brick, when you put the brick like this, it is going to give you lesser pressure, because the surface area in contact is more. If you put it like this, it will be slightly more pressure, because surface area is this is less than this one. But when you put it like this, then the pressure exerted will be maximum, because the surface area is the least. So that's what they are given you. A block of mass of 10 kg of dimension 40 by 20 by 10 centimeters lying on the tabletop. On its sides, 40 centimeter by 20 centimeter, the thrust acted by the block of the tabletop is equal to the weight of the block, that is 10 kgf. The thrust acts on the area 40 into 20, so 800 centimeter square. So the pressure is 10 upon 800, that is 0.125. Okay, so it was, let's consider that this is 40 and this is 20. So 40 into 20, so when it is acting like this completely is 10 kg. So 10 kg upon 40 into 20, that is 10 kg upon 800 centimeter square. That's 0.0125 kg centimeter square. Now if the block is turned so that it lies on its side 20 by 10 as shown in the figure. So if it is acting like this, okay, if it is acting like this, then what happens over here now? Then it is only by 20 by 10 it is lying on. This is 20. So you can see this part is 20, this was 40. Now this is 10, 20 and this is only 10. So 20 by 10 which is acting like this. So automatically the complete 10 kgf is resting on 20 by 10, that is 10 upon 20 into 10 is 200. So that is 10 upon 200. 10 upon 200 is 0.05. So you can see that the pressure exerted when I put it this way was much higher as I placed it on this way. So now if the block is turned and it lies on the size 20 cm by 10 cm as shown in the figure, the thrust exerted by the block on the tabletop is the same, equal to 10 kgf. This thrust now acts on the area A2, that is 20 cm by 10 cm, that is 200 cm square. The pressure on the tabletop is now 10 upon 200 is 0.05 kg centimeter square. Thus, pressure exerted on the body depends on the surface area on which the thrust of the body acts. Smaller the surface area, more is the pressure exerted by the thrust, and larger surface area, lesser the pressure exerted by the same thrust. Okay, so that is what we understood last time, earlier also. The next is dependence of the pressure on the thrust. So a thin boy is standing on a brick kept on a bed. So there is a thin boy and a thick boy or fat boy. He exerts some pressure due to its weight. But in figure 3.17b, a fat boy is standing on the same brick kept on a bed. In this case, the pressure exerted by the fat boy is more due to his more weight. Thus, greater the thrust on the surface, more is the pressure on it. Okay, so greater the thrust on the surface, more will be the pressure. So accordingly we see magnitude of thrust, magnitude of force. Whose magnitude was greater? The fat boy's magnitude of force was greater. Fat boy weight was greater. That's why his magnitude of thrust is greater. Thin boy has got a very less amount of magnitude of thrust. Hence, his pressure exerted by him is less. Thus, greater the thrust on the surface, more is the pressure on it. While smaller the thrust on the surface, same surface, less is the pressure on it. So this is how we can see that how the things are going to be dependent on how the two factors on which the pressure depends. The first factor was the cross-section area, that is area of surface area contact between the body and the surface, and the second one is the weight of the body, or we can say the thrust or the magnitude of the thrust applied by the body. So that was about the factors affecting the pressure. We'll continue for the next part in the next video.